Hello friends, in this lecture we discuss construction of Turing machine for a language L that is described as an occurrence of zeros which is followed by n occurrence of 1 and that is also followed by n occurrence of 2's. Okay, and n is greater than equals to 1 like this. If we suppose a w which is belongs to L and we consider w like this, means all the string which is belongs to L having equal number of zeros, ones and twos, and zeros followed by ones and ones followed by two only. Okay, so this is about the language. And now we consider, because we have to construct a Turing machine for this language L that accept all string w which is belongs to L and reject all string which is not belongs to L. Therefore here we starting a construction of Turing machine. Before this we discuss the initial instantaneous description id, like this. Okay, suppose this is our input tape and this is our initial state q0, and the string is 001122, and this is our actually input string over the infinite tape of Turing machine, where the initial state is q0, which is appointing the first alphabet or a symbol of a string of w like this. In this case a w is 0011 and 22. This string w is surrounded by number of blanks, okay, in both side, because the blank is denoted here by B, and that is the by default symbols over this tape which which indicate the absence of input symbol. Okay, so after assuming this initial instantaneous description, we are here starting the construction of Turing machine. Okay, so we move to the next situation like this. Here we construct this transaction table and start with the initial instantaneous description. Okay, so we first assume, as in previous, our initial instantaneous description is this. Okay, when the description about this initial instantaneous description is given as earlier, where this is our uh, input string w that is surrounded by number of blanks, and our initial state is q0, which is we assume. So the transaction table having also initial state q0 like this. Okay, now of course if we think over this and if we think over the logic for the solution of this language L, then that is very simple and as similar to the language L uh, having 0 to the power n and 1 to the power n. Okay, and n is greater than equals to 1. For this language we already constructed our Turing machine in our previous lecture. So the logic of construction of Turing machine for this language L is similar to the problem this. And suppose if this is L1, so that is similar to this language L1. Okay, so and in so the logic of constructing Turing machine for this language L is we move, we take a pass, and in each pass we convert the first 0 by x and moving on right hand side direction, then first one by y and moving on right hand side direction, and in and the first two by z. Okay, after converting this first 2 by z we take a left turn. Okay, here before we moving on right hand side direction, and in a left hand side direction when we convert this first 2 by z, then we take a left turn and moving until we reach the first x, which is indicating the conversion of this 0 by x. So until we reach to this x we take a left turns. Okay, Once we reach to x, to this situation where we read x at a particular state, then again we take a right turn, and that is the initiate the phase second. So I repeat, in a first phase we moving from left to right and replacing the occurrence of first 0 1 and 2 respectively, x y z, and after taking left turn and again moving to the first x. Okay, so this is our phase 1. After completing phase 1, we are moving in a phase second, and this is up to we get the zeros, okay, which we discuss in later. And after stopping the situation where we don't get any uh, zero at an initial state like this, at this situation if we don't get any input zero, then we moving into the next phase, that is known as acceptance or rejection case. And in the acceptance and rejection case, we count the number of zeros, ones, and two. And this will definitely we will learn in this example. Okay, so we discuss this all things one by one. So here we are at initial state q0, and we are reading first symbol of string w, that is 0. So according to the logic, this 0 is replaced by x and move on right hand side, and we start the first phase of this construction. So we first write a transaction function. The transaction function is this: whenever we read a 0 at input tape, okay, and then that 0 is replaced by x and taking the right turn and changing the state from q0 to q1. Okay, so if we apply this transaction function, then we get this transaction sequence. Next, the next situation like this. Okay, so after taking this first move, this is the initiation of phase 1, and this time in a phase 1 we are moving on right hand side direction. Okay, each phase having a two direction: first is left to right, and second is right to left. Okay, I hope you understand this. Okay, so now we move to a next situation where uh, where we are in a situation, this which is converted into this form in a previous slide. Now the second thing is what we have a situation like this at current situation. Okay, we are at state q1 and we're reading 0. Okay, so again this 0 is without changing this 0, we are taking the right turn, and 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 without changing the state also. Okay, when we read, a simple thing is what we have to convert first 0 of string w by its corresponding tape symbol, that is x, and after that all zeros are just passed, because we are in interest to find out the first one only. So therefore this 0 is just pass and we take the right turn. Okay, for this we don't have any transaction function, so we first write a transaction function into a transaction table, that is like this: whenever we are at state q1 and we're reading 0 at the input tape, then that 0 is remain unchanged and taking right turn and without changing the state. Okay, so we apply this transaction function at this situation, and we get the next transaction sequence like this. Okay, I hope you understand this. Now the thing is change, and we are in this situation. Okay, so here we are reading a q1, sorry, 1 at a new state q1. Okay, earlier we read first 0 at q0, here we read first 1 at q1. Okay, so this one should be replaced by its corresponding tape symbol, that is we assumed y. Okay, so we change this 1 by y and taking right hand side right turn and change the state. Okay, for this, of course, we don't have any transaction function, so we first write a transaction function. Okay, and the transaction function is this: whenever we are at state q1 and we're reading 1 at the input tape. Okay, and this input is under read write head. Okay, this is our read write head, so under this is 1, so we are reading 1 at current state q1. Okay, this is simply means of this table. So the current state is q1 and we're reading 1, so this 1 is replaced by y and taking right turn and changing the state q2. Okay, so if we apply this transaction function, then we are in this situation. Okay, so we change this 1 by y. Okay, and taking the right turn, and we are in new position, that is in state q2. Okay, I hope you understand this. Now the scenario is changed, and with the current thing is this. Okay, at this we are reading 1 at q2. Of course, this is the this is again a new situation, and of course we know, according to the logic, when we pass when we overwrite first 1 by y, then we just pass all further ones. Okay, because we are in interest to find out the first two. Okay, so therefore we just pass this one, and of course this is indicated by this situation. Okay, you notice this is a unique situation. Whenever we read 0 at q1, we just pass that. Okay, by using this transaction function. Okay, and whenever we read 1 at q2, then we just pass this 1. Okay, for that we have to write a transaction function. So the transaction function is this: whenever we are at state q2 and we are reading 1, we have to just pass it by using this transaction function. So we apply this transaction function at this instantaneous description. Okay, so we move to a next situation like this. Here what we did, we just pass this one, and without changing state, we take a right turn. At this situation, we're reading 2. So whenever we are reading 2 at state q2, it simply means that is the first 2. Okay, in the direction left to right, which need to be which need to be changed by z. Okay, and again, of course, we know this time we are in state we are in phase 1, so this is first time 2 at a state q2. So the simple thing is, what whenever we reading a q 2 at a state q2, that is just passed, sorry, that is not passed, that is replaced by z and taking the left turn. Because in a left to right move, in each pass, we just replace the first occurrence of 0 and 1 and 2 by its corresponding tape symbol x, y, and z. So when we override this first 2 by z, we just take a left turn, because when at this time we are moving from right to left, and again start second phase. Okay, so for that, first we have to write a transaction function. So we write a transaction function like this: whenever we are at state q2 and we're reading 2, so we replace this 2 by this z. This is a tape symbol, and we're taking the left turn, and this time we're changing the state q3. Okay, when we apply this transaction function, then we get this instantaneous description. Okay, at this first two is replaced by z, and we take a left turn, and we change the state q3. Okay, and this is the left side moves. We are taking turn from right to left, and this is in phase 1. Okay, and in this phase 1, now we move a, a leftmost side until we reach to this x indicating the left edge of your string w. Okay, so remaining string w. Okay, because the first element of w is this x. Okay, this time. Okay. um, okay, so we just take a left turn for all the situation. How it is, let us discuss. So the thing is changed now, and we are in situation like this. Okay, so this is our current situation. At this situation again, whenever we read one at state q3, a q3 is means we just take a left turn. Okay, whatever we are reading at state q3, we just pass that, but x is not passed. When we reach to a x means when we read x at q3 state, then we take again right turn. Okay, so let us discuss first. Here we are reading 1 at q3, so we take a left turn, and without changing this one, for that we have to write a transaction function. So we first write a transaction function like this. Whenever we are at q3 and we're reading 1, then 1 is replaced by 1 and taking left turn, and without changing the state q3. Okay, when we apply this transaction function at this initial instantaneous at this instantaneous description, then we move to this situation. This one is just pass, and we take a left turn, and again state remain unchanged q3. Again we just pass. Okay, and we are in this situation right now. Okay, so look, at this time our transaction table having more symbols x, y, and z also. Okay, um, because they also encountered at the input tape. Our tape symbol, these are our tape symbol: 0, 1, 2, x, y, z, and blank. This is tape symbol, and that is represented by top. Okay, which is the common thing of a Turing machine. Okay, so here when we read y at q3, of course for this y we just pass it and take a left turn. Okay, according to the logic. For that we have to write a transaction function first. So we write a transaction function at this situation for a q3 like this. Whenever we are at state q3 and we're reading y, then just y is just pass, and we take a left turn and changing the state without changing the state q3. So we apply this transaction function at this instantaneous description, then we next move to this situation. Okay, okay, so this is the next instantaneous description. I think it is clear now. Again we are taking a left turn. Okay, and hmm, okay, so at this situation again we are reading 0 at q3, and we take a left turn. For that we first write a transaction function. Okay, the transaction function is this. Now we apply this transaction function at this, and we reach to this situation. Okay, so this time we reach to this situation. Okay, so I think it is clear. Okay, so look, when we are at this situation tell us uh, the left to right moves and right to left moves in a in a phase one or a pass one. Okay, is completed. Okay, and now we starting a next pass or a phase. Okay, so here we say phase second will be started after taking a right turn. Okay, this is indicating a triggering situation to move from phase 1 to phase second, or pass 1 to pass 2. Okay, so whenever we read x at q3, then we just change the state again into an initial state and take a right turn. Okay, so we again come to this situation. So for that we first write a transaction function. The transaction function is like this. Okay, whenever you are at state q3, you're reading x, then x is replaced by x and taking right turn, and state change into a q0. This is the transaction function. We apply this transaction function at this instantaneous description, then this phase one is end, and we enter into second phase like this. Okay, so we are at this situation now. The thing is change, and we we are in a situation like this. So this is our second phase, initiation of second phase. Sorry. Okay, so here we start from this phase again according to the previous phase, phase 1. Okay, according to this phase, okay, sorry for interrupt. So this is our second phase starting, and again as similar to phase 1, we replace this 0 by x, and moving on right hand side, whenever we read 1, then 1 is replaced by y and z. Whenever we read 2, then 2 is again overwrite by z, and again taking left turn. Okay, so in a phase second, we start with this situation, and for this we have already a transaction function, so we apply this transaction function here at this situation like this. So this is the phase second, and we apply this transaction, and as similar to phase 1, first move on right side, and for that we apply a transaction function this. Okay, so like this. So we move to a situation like this. Okay, again whenever we read y at q1, of course that is just pass away, because we are in interest of 1 only. So this is passed by using our next transaction function like this. So we apply this transaction function at this instantaneous description. Okay, and we move to a next situation like this. Okay, at this time again, as in phase 1, we had read 0 at q0 state and 1 at q1 state. So this is telling us this is the first, or respective occurrence. Okay, according to the zeros 1 and 2. So this respective sequence, when we read 1 at q1, then it should be replaced by y and taking right turn. Okay, so for that we already having a transaction function. Okay, we already having a transaction function like this. So we apply this transaction function at this situation. Okay, so we change like this. Okay, mm, like this. Okay, so this is converted like this. Okay, we apply this transaction function. Now we are taking again, mm, okay, so this is our next instantaneous description after converting this 1 by y and taking a right turn. Okay, by a transaction function this. Okay, at this side we are reading a z. This z is just passed. Okay, so we just pass this z, and we taking the right we are moving on right hand side. Okay, so for that we have to write a transaction function. So that transaction function is like this. Okay, here we write a transaction function. Okay, whenever we read z, okay, at state q2, then we just pass z by z and taking right turn without changing the state. Okay, so when we apply this transaction function, we reach to a next transaction sequence like this. I hope you understand. So this Z is just override by Z again, and we just take a right turn. Okay. This time we are reading 2 at Q2. Of course, we know when we read 2 at state Q2, then that is replaced by Z and taking the left turn. As similar to phase 1, and for that we already having a transaction function. Okay, this. So we apply this transaction function. Okay, and for that we apply at this time this transaction function. So we change to this situation. Okay, left hand side. Okay, so when we read 2 at q2, we just apply this transaction function and moving to this next instantaneous description. And this is the left moves, or you can say right to left hand side direction in a phase second, and when we moving from right to left in a phase second, then we just pass all the things until we reach to a x. Okay, so again as previous we applied all, because we already having all transaction, so we just apply a transaction function one by one and moving on left hand side direction like this. Okay, so this z is replaced by z and moving right hand left hand side. For that we just write a transaction function at state q3, because this is the first time occurrence when we read z at q3, so we write this transaction function again because this is just to pass. Okay, so after applying this transaction function at this instantaneous description, we move to a next situation like this. For this, we already have a transaction function. For this, y is replaced by y and taking the left hand side turn. Okay, so we are moving in this way. Next, this y is similarly previous step pass away and we take a left turn. Okay, so we're taking a left turn and like this, and we reach to this situation, and this situation telling us the second phase is completed and we turn into a next phase. Okay, so for this we already having a transaction function, and this we apply this transaction function at this instantaneous description. So we take a right turn again. Okay, this is second end of second phase, and now we come to a situation this. Okay, so we come to a situation this. Okay, so here phase 3 is not initiated, because if we read 0 at this q0, it means we start the phase 3, but this time the phase 3 is not started. Because how we identify this, because we are reading y at q0. Okay, and q0 is our initial state. If we read 0, then we are entered into a next phase. So this is telling, this situation telling us your second phase is not initiated. Okay, and you have to take the decision of acceptance or rejection, because the number of 0 is completed and both are uh, in turn replaced by x. Okay, and so here we have to check for the acceptance and rejection. Therefore the next phase is what, the checking of acceptance or rejection. Okay, so once we read a y at q0, here we're taking one another turn for acceptance and rejection. So when we read y at q0, then that y is just replaced by just passed by itself again, means y is override by y again, and we are taking the right turn. In this time we just change the opposite turn, means we are not in the phases like phase 1 or phase 2. We don't enter onto those phases. We are taking one another direction. In that direction we just checking the acceptance and rejection. If in this direction, if we not found any remaining 1 or 2, okay, in its right hand side direction, it means the number of zeros, ones and z's are equal. Okay, so we declare the acceptance. If we read 1 or 2 in a right hand side direction, okay, then it means the either uh, one is greater than to the 0, or if 2 is found, it means 2 is greater than to 0. Okay, so these will be the cases. So for this we are write a new transaction functions. Okay, so whenever we read y at q0, y at q0, then that y is replaced by y, and taking right hand side turn and change the state q4. When we apply this transaction at this situation, then we move to a next situation like this. Okay, I hope you understand. Again when we read q4, okay, when we read y at q4, then that is also passed. Okay, because it is indicating that uh, that there is no 1. Okay, if we read 1 at q4, then it is halt situation. Okay, okay, so we just pass this y by y by taking a next mm, transaction function. For this we have to write again transaction function, and we write a next transaction function at a state q4, that is y. When we read y at r, then we move to state q4 again and just pass this y. When we apply this transaction function at this instantaneous description, then we get a next transaction sequence like this. At this situation, uh, when we read y at at state q4, it's simply indicating that in a right hand side direction there is no remaining 1. Okay, now when we read z at q4, then we are checking for remaining 2's if those are there. Okay, so if we are reading z, then we just pass this z and taking right hand side direction. This time we change the state. Okay, uh, that is for the checking for remaining twos, therefore there is a need to change the state. Okay, so okay, we apply a next transaction function, and that is before we have to write. So q4, when we read z, so here we write a next transaction function. Okay, like this, then z is replaced by z and taking right hand side and changing the state. And when we apply this transaction function, we reach to a next situation like this. I hope you understand. Okay, so again the next direction is, now this is the situation when we read a z at q5, then this is also just pass. Okay, and for that we have to write once again one new transaction function at q5. Okay, so we first write state q5. This is state q5, and we write one another transaction function like this. And when we apply this transaction function at this instantaneous description, then we move to a next situation like this. Of course, this is a new situation. If we read uh, blank at state q5, it's simply telling us there is a equal number of zeros, ones and twos. If we reach to this new situation where we are at state q5 and we're reading blank, so this is indicating of acceptance. So once again we write one another um, transaction function at state q5 at the blank, that is like this. And whenever we read blank at q5, and then we take the right turn, and you can take a left turn also, it's on choice, and change the state qf. Okay, so when we apply this transaction function, that is this, and we reach to this situation. Okay, this situation telling us we are at a final state, and the occurrence of zeros, ones and twos are equal, and number of zeros is followed by number of ones, and the number of ones is followed by number of twos only. So this is the case, and this is the, of course this is a halting situation, because you may notice here we don't have any transaction function. Okay, so this situation is halting situation, and halting at fine, halting and acceptance. Okay, why it is acceptance? Because our q5 is a final state. This is our a final state. Okay, we mark this as a final state like this. Okay, so therefore we are accepted our string w. I hope you understand this. Okay, and this is very simple, student. Okay, so let's move for a further examples over this final transaction table, or for the case which is not belongs to this. Okay, so this is the final table, transaction table. Okay, okay, let's look at this string w. Here w is 00 and 1 and 2. of course it is not, this W is not belongs to this L. So this Turing machine should reject this W, because there is no equal number of zeros 1 and 2. And when we apply a transaction sequence at this, then you can notice, of course this is not accepted. This is our transaction table. Okay, so we apply this transaction table at this situation. Then when we read a 0 at q0, okay, we just pass by using this transaction function. We replace this 0 by x and taking right hand side direction. When we read 0 at q1, okay, then we just pass this 0 and take a right turn. When we read 1 at q1 state, then we apply this transaction function. Then we change this 1 by y and taking right hand side direction. Okay, right hand side turn. Okay, when we are at a state q2 and we're reading a 2, it simply means that this is also replaced by z. By using this transaction function, we just replace this 2 by z and taking this time left turn. Okay, left turn. So at this situation, whenever we are at in state q3, we just take a left turns, and because we have to reach at this x. Okay, so after applying this left turn, we are again apply left turn and left turn, and we reach to a situation where we read x at q3. Of course, this is the end of phase 1. Okay, now we turn into a second phase by applying again this transaction function. Okay, this is triggering a next phase always. Therefore we are in a next phase. So here again we are reading this 0 at q0, so we start this time a next phase. Okay, again we replace this x, this 0 by x, and taking a right hand side turn. Okay, and at this situation we are reading y at q1. Okay, and you notice that this is a first situation. Okay, and for that we don't have any transaction function, because at q1 either we read uh, sorry, at q1 state we just read 1, and that 1 is replaced by again, means what, again replaced by y. Okay, okay, so we read 1 and we replaced by that. Okay, so but this situation is halting situation, because we don't have any transaction function. You can see for this state q1 and for the y. Okay, for the y we don't sorry, we have have a situation for y. Okay, that y is replaced because we have to just pass this y, and when we read 1, then that one is replaced by y, and taking right turn and changing the state into a q2. Okay, so when we apply this transaction function, we are reading this, but here we don't get 1 and we just read z, and this is the halting situation. Okay, you can notice for this we don't have any transaction function. For this q1 we don't have any transaction function here. So this is a halting situation, and this halting at a non-final state, because this is the q1 state, so this is called a rejection. I hope you understand. So this w is not belongs to L, therefore it is rejected. Okay, for this same case we have another example. In this case, sorry, for this we already discussed. Okay, so sorry, so okay, look at this situation. Okay, this is the string w, which is also not belongs to L, because in this there is also no equal number of zeros, 1 and 2s. So when we taking this transaction function, then we reach to a situation this. At this situation we're reading 2 at state q5. Okay, and this is telling the halting situation, because for this we don't have any transaction function. So this is a halting situation, and this halting situation is at non-final state q4 q5. That is also a rejection case. Okay, I hope you understand this. again. So finally our answer is this Turing machine, this transaction table. Okay, so next here we discuss a tuples are required to design this Turing machine. According to this transaction table, we design a, tuples. Okay, so those tuples are these. This is the set of state, and this is the tape symbol. The tape symbol is 0, 1, and 2, x, y, and z, and blank, because these are at tape and used for reading purpose at the input tape. Of course, B is a blank symbol, sigma is 0, 1, Q0 is initial state, and QF is final state. And transaction function in a form of transaction table is given like this. Okay. So these are the tuple. One new case for this is also very important. Suppose we have a language like this. Okay. So this language is telling us that when when n is greater than equals to 0, earlier it was 1. Okay. Uh, it was 1. So if n is greater than equals to 0, it simply means when n is equals to 0 means there is no occurrence of zeros, 1 and 2. It means that L consists null string. If this language L consists this null string, it means we are reading null at initial state, and that null is what, in a blank form. Okay, like this is our initial instantaneous description when we are at a initial state q0 and we're reading this blank. For that blank, if we want to accept this null, okay, if suppose our language L is defined like this, then we have to include one more transaction. Okay, like whenever we are reading blank at q0, whenever we are reading blank at q0, then just pass and we take a right turn, or you can take a left turn and change the state into a final state. Okay, like this. Okay, this time we are taking a right turn and change the state into a q final. When we apply this no, transaction function, then we reach to this situation. Okay, of course we are at final state, and it means that there is an equal number of zeros, 1 and 2's also. Okay, so this is a acceptance situation. Okay, I hope you understand this. Thank you very much for watching this video, and the reference of this is KLP Mishra, Sudcam, and Silber and Peter Lynch. Thank you very much.